in question 3, I have to try to provide predicate tables which make all of A to E false. So yeah, so I might start with formula A, and the reason for that is because it's a conditional, and if I want to make the conditional false, then that means I have to have a 1 here and a 0 here. So that's because I wanted to get out a value straight away that I could write into the table. So I've got the value of FA, which is 1. And I know that over here I have to have the value false for this disjunction. So that means that JAA and JBB both have to be false. JAA is false and JBB is false. And so now I've made that formula false. Next up, why don't I do D? Because that looks like another arrow. So I'm going to make it false there, and that means this has to be true and this has to be false, this whole big bracket here. So for that negation to be true, then JCB has to be false. JCB is false. And this whole long bracket here has to be false. So that means that one of these 3 things, at least one of them, has to be false. Yeah, I'm not going to sort of pick which one it is right now. I'm just going to come back to the fact a bit later on, once we have some more information. I'm going to come back to the fact that at least one of these has to be false. So why don't I look at C next, because that's also that's also an arrow. So for C, I've got the arrow needs to be false, so this long whole conjunction has to be true, and this JCB has to be false. So is JCB false? Yes, it already is, so that's good. If I found out that JCB had to be true and we already had the value 0 in there, for example, then that would show that there's a contradiction, and so that would show that these formulas can't be all true together. These formulas can't all be false together. But at the moment it's agreeing, so that's fine. So we'll just have to see if we can get through all of them without any disagreements in value. So got false for JCB, and this whole long conjunction has to be true, which means that every part of it has to be true. So I'm going to read off. I've got GC is true, and GA is true. Also FA is true. That agrees with what I had earlier. JCC is true, and JCA is true. JCA is true. Great. So I can tick that one off because all of them, yep, from what I've written down the table, all of those, that makes the whole formula false. So I wonder if I can come back to D over here and see if there's, so remember I needed at least one of these to be false. So do I have some more information about that? Well, here's an example. I've got JCA over here that I filled out now, and that is true. And JCA is true. And so the negation of that, the negation of JCA will be false. Sorry, I apologize for that. The negation of JCA will be false. And that fulfills my requirement because I wanted at least one of these conjuncts for the whole conjunction to be false. I needed at least one of them to be false. And we found one. This first one over here is false. So now it doesn't matter what the values are of these other two. I can tick off formula D because I've succeeded in making that one false. Next up, why don't I look at formula E, because I think I have some information that could make that one false now. So if I want this whole thing to be false, then at least one of these conjuncts has to be false. So I've got if A is true, so that's not false, that doesn't help me, but I've got GA as true, which makes the negation of GA be false. So this conjunct is false, therefore the whole thing is false. And so it doesn't matter what JAA's value is really, so I can tick that one off as well. And now we're just down to the last one, which has a bunch of biconditionals. So if I want the whole thing to be false, then I need these two biconditionals to have different values. So let's fill out what I know. I know that GA and FA, and the values of those are both true. So that makes the value of this biconditional be true. So for this biconditional, the main one, to be false, I need the second biconditional's value to be false, so that they have different values. So JCA has to have a different value to JAC. Now, is it the case? I've actually got JCA, and that is a 1, and JAC, I have nothing there, so I have to make, since JCA was a 1, I have to make JAC a 0. So I've got a 0, and that makes all of A to E be false using this table. And again, these are the only values that sort of matter to make it false, but I can fill out the rest of them. And why don't I fill them all out with zeros? But I could do a mixture if I chose. And question 4 asks, if you can find predicate tables which make a set of formulas true, does that mean you can find predicate tables which make the set false? Now you might think so, because that's the experience I've had with A to E. In question 2 we found some tables which made them all true, and in question 3 we found some tables which made them all false. But that's actually not always the case. So a counterexample would be, let's just say I had this formula, maybe among some other formulas. Now, could I find some predicate tables which make this formula true? Yep. In fact, even this one that I've got now would do. But can I find any predicate tables which make this formula false? No, I can't. There is no way that there's no set of predicate tables that can make FA not imply FA. That's because it's actually a tautology. So it's a logical truth. So it's whatever predicate tables you come up with, this will be true. So yeah, I'll sort of leave that as a clue for you to sort of answer the second question. So if we used a tautology, something that's always true, to answer this question, what might we use to answer the second question, which is kind of the opposite?